Hello everyone. Today let's discuss depth first search algorithm, right? So this is basically a fundamental graph traversal technique, right? So mainly we use DFS to explore all the vertices means nodes and edges of a graph. So basically it starts with a specified node. It starts with a start node basically. So it starts with a specified node. Suppose this is node. I'm taking this one. Example, this is start node. And it explores as far, it explores as far as possible along each branch before backtracking, right? It explores all the possible combinations. That's what they are trying to say. So before backtracking, right? Backtracking is before starting from that point itself again. So in this implementation, we will be utilizing this one, recursion. Basically, we'll be making use of the utilization. Recursion. So we'll be making use of the recursion helper function to visit each node and keep track of the visited nodes to avoid cycles. So we'll be making use of the recursive helper function in this case. So you can go for the iterative approach as well. Let's go with the recursive approach, right? Recursive helper function will be making use of to visit each node. So here to visit each node, we'll be making use of the recursive helper function and we will keep track of the visited node. So we will keep track after visiting this node, we will we'll mark this one as visited, and then why we'll do this one every time we visit node, we will mark them as visited, right? Why do we do that? Basically to avoid the cycles. So again visiting and again visiting the same node, that shouldn't happen, right? So to avoid the cycles, basically we'll be marking that one as visited. So this is the approach. Let's start writing the code, and I'll just explain with simple example, and then later we will discuss about the time complexity and the space complexity. So initially I'll just give your function DFS of graph start. So let's initialize an array to keep track of the visited nodes first, defaulting to false. So I'll just give here, let me take visited itself, this one. We have to initialize the array, right? So I'll just consider array of length of the graph, and let's fill this one with Boolean values false initially. So next, basically we'll declare the array. We need to store the order in which nodes are visited, right? Similarly, if you have followed the DFS, you will be knowing, right? We have to store the order in which the nodes are visited. So for that, I'll just declare the array. So I'll just give here, let me completely take this one, result, and I'll initialize the empty array. Next, I'll just make use of the helper function to explore the nodes recursively. So I'll just give here function, let me give explore here, explore of node. So this is one thing. If the node has already been visited, then we will return to avoid processing it again. So it shouldn't form cycle, right? So if node has already been visited, then we will just return, right? We'll return nothing. We'll just make use of the return. So I'll just give in this way. So visited, we are considering in array, right? I'll just consider node, will just make use of return. So we have next step, we have to mark the current node as visited, as it is already visited. So we can just write here visited of the particular node. We will set this one to Boolean value true. Next, let's add the current node to the result array. For adding, I'll just make use of the push current node, right? We have to add. So here after visiting, we have to add the current. So then this is fine. So next what we will do, let's iterate over each neighbor of the current node. We will be iterating over all the nodes, all the neighbors of the current node one by one. For this, after initialization, let's go for the iteration. Nothing but I'll just consider neighbor of all the nodes, right? I can just give in this way, graph of node. So here, if the neighbor hasn't been visited yet, then we will explore it recursively. So let's make use of the recursive function if neighbor hasn't been visited yet. So we can write visited of neighbor equals undefined, or not of visited of individual neighbor, right? So this one I have considered function explore, right? So we will recursively explore it. So I'll just give here explore neighbor. So I hope this is fine. Next step is we have to start the exploration from the specified start node. So let me give here explore of start. So I hope this is clear. Finally, we will return the order in which nodes are visited. So let me give here return result. So this is it for the code. Let's try to understand with the example. Similarly, what we did for BFS, right? So I'll just consider graph. So let me consider here first one, 1, 2, 3. So basically node 0 is connected to the nodes 1, 2, 3. Again here next is node 1. Node 1, let's connect this one to the node 0, 4, 5. Let me give in this way. So let me leave space over here so that this looks good, right? So node 2 is connected to 0, 6. I'll just give here some random number 0, 6. And node 3 is connected to node 3, 4 and 5 are connected to 0, 1, 1. Let me write like this. This has to be 0. Let me take 1 here. Let me take 1 here. Finally, node 6 is connected to node 2. So this is just for the example sake. So next what we will do, let's specify the starting node for the BFS travel. So let me give const start node has to be 0, right? So let me consider this start node equals 0. Also what I'll do, let's call the DFS function and store the result. We need the result, right? We have to store the result. So I'll just give this one, take the variable name result, and let's call the DFS function, and we have the parameters graph and start, right? Let me copy this one. Graph and start node we need actually. Let me change this one to start node. Start node, right? We have to start from the first one that we considered as start node. So finally, we will log the order of the nodes visited to the console for printing purpose, right? So I'll just make use of console log of here. Within the backticks, let me give DFS order of nodes. Let me give in this way. So I hope this is clear. So let's see, our output has to be 0, 1, 4, 5, 2, 6, 3. So let me run this one. So if not a visited of neighbor, reference error visited. So here I have misspelled visited, right? Line number 11. So I'll just come here. Okay. Let me run this one again. Yeah, here the DFS order of the node 0, 1, 4, 5, 2, 6, 3. So we are getting the output correct. We are starting from the start node and we are exploring all the possible this one through the DFS, right? We'll be making use of the DFS and we will be finding the DFS order of the nodes. So DFS order of the nodes that we have got here is correct, 0, 1, 4, 5, 2, 6, 3. So let's discuss about the time complexity and the space complexity. So the overall time complexity would be big O of V plus E. Nothing but V is, we know that number of vertices or nodes. E is nothing but number of edges. So overall time complexity would be big O of V plus E. And what would be the space complexity? It would be big O of V, because we are storing visited nodes and also we are making use of the recursion stack. We have to keep in mind. So the time complexity would be big O of V plus E. And finally, the space complexity would be, I'll just give here. The space complexity would be big O of V. So I hope this is clear, right? So yeah, this is it. Thanks for watching, guys.